All right, let's take a look at the definition of a derivative function. All right, so what we've done so far is find the derivative at a certain point on a graph, okay, or the slope at a certain point. This right here is the definition of a derivative function. So write this down in your notes. Right? Basically, all we're doing, or all we're changing from our last definition of slope at a point, is replacing a with x here. We're just leaving this as a variable instead of plugging in a specific value. All right, now this notation here, f prime of x, that means the derivative. Okay, f prime of x stands for the derivative function. So a derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x over h, and this is going to allow us to find derivatives of certain functions. All right, so let's take a look at an example. All right. There we go. All right. So let's say my original function is, I don't know, 4x plus 7. All right, we'll start with something easy. So to find the derivative of this, to find f prime of x, that's going to be the limit as h approaches 0 of f of x plus h minus f of x. Oops. Still getting used to this pen here. All over h. So we need to figure out what f of x plus h is. Right? Well, all I'm going to do is in my function plug in x plus h for x. So I like to come off to the side and figure that out. So f of x plus h is just going to be 4 times x plus h plus 7, like that. So we can go ahead and distribute that 4 through and say this is going to be 4x plus 4h plus 7. So now I'm going to plug that in for f of x plus h here. So this is going to be the limit as h approaches 0 of 4x plus 4h plus 7 minus the function. So the function itself is just 4x plus 7 all over h. Okay, now at this stage, all right, again, just like in our last lesson, some things should cancel, right? So here I've got 4x minus 4x. Those will cancel. And I've got 7 minus 7. Those will cancel. So all I'm left with is the limit as h approaches 0 of 4h over h. Clearly, these h's will cancel, and I'm just left with 4. Right? So here I actually don't have anything to even plug in. Right? There are no h's left. The answer is just 4. So f prime of x is equal to 4. That's my entire function. No matter what point I choose, the slope is equal to 4. Now, if we think about algebra, that should make sense, right? Our original function was just a line. No matter where we are on that line, the slope is equal to 4. Right? So let's try another example here. How about, there we go. Let's say our original function f of x is equal to, I don't know, x squared plus 2x minus 5. Right? So I want to find the derivative function here. Well, our definition of the derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. So again, I'm going to come off to the side here and figure out what f of x plus h looks like. So I'm plugging x plus h in everywhere I see an x. So that's going to be x plus h squared plus 2 times x plus h minus 5. So I want to go ahead and expand this out. So this will be x squared plus 2xh plus h squared. And here we'll have plus 2x plus 2h minus 5. So I'm going to go ahead and plug that whole thing in here for f of x plus h. So this will become the limit as h approaches 0 of x squared plus 2xh plus h squared plus 2x plus 2h minus 5, then minus f of x. So minus x squared plus 2x minus 5, all of that over h. And again, remember, some things better cancel out here. So I've got x squared minus x squared, so those will cancel. I've got 2x minus 2x, so those will cancel, and I've got negative 5 minus negative 5, so those will cancel. And all I'm left with then is the limit as h approaches 0 of 2xh plus h squared plus 2h all over h. So here, in my numerator, I can factor an h out of everything. So the limit as h approaches 0 of h times 2x plus h plus 2, all of that over h still. Now these h's will cancel, and I'm left with the limit as h approaches 0 of just 2x plus h plus 2. Now I can plug in my 0 for h, and my answer is 2x plus 2. Now this function, and I'm going to write it again down here, is f prime of x equals 2x plus 2. This function will tell me the slope at any point on this graph. Okay? That's the significance of a derivative function. Right? So if I said, well, what's the instantaneous rate of change, or the slope of x squared plus 2x minus 5 at 7? Well, I would just plug 7 into the derivative, and that would tell me the slope of this function. So, I mean, that would be f prime of 7 equals 2 times 7 plus 2. So 14 plus 2 is 16. So the slope at x equals 7 of this graph is equal to 16. Right? So this function, the derivative function, will tell me the slope at any point on my original graph. Right? So the last thing that we just want to mention here is the notation. Right? There are a lot of different ways that we're going to look at for notation. Okay? The one that we've looked at so far to denote a derivative is f prime of x. Okay? That tells me we're talking about a derivative function. Now, these 4 other ways. Okay, you're going to see all of these ways to denote a derivative. Right? So, for example, this first one, right, instead of saying f of x equals something, right, we sometimes just write y equals 2x minus 7. Well, then I could say, if I'm finding the derivative, I could just denote that as y prime, and then go through my process of finding the derivative. Okay, dy dx is another common way that we're going to use to represent derivative. And these 3 come from our definition of slope, right? Change in y over change in x, or dy over dx. Right? Now, this notation is really similar. Instead of just writing a y, we write an f, right, for function, right? That's function notation. Same thing here, right? D over dx of our function. Now this you may see, d over dx of 2x minus 7, right? That means take the derivative of 2x minus 7. Right? That's what these notations mean. So I would certainly make sure that you put all of these in your notes as well. All right. So there is a Math Excel assignment up. It's very short. It's only 4 questions for you guys to practice this. And then in our next lesson, we will kind of dive into looking at derivatives from graphs.